going around looking at who's here, and things like there's a new sustainability institution for professionals. I got things gathering pace, which is interesting because it's pretty difficult to get some of these ideas embedded in the general population.
Yeah. No doubt it's going to come up again today because all the pollution in the air, and we're going to say, why?
Wales is clear.
Yes.
It's a nasty English problem.
Right. Well, good morning, ladies and gentlemen. Let's go for it. It's I see that you've brushed off the Saharan dust off your shoes. So, welcome to this session, which is a keynote session on the future of energy recovery. And what we're aiming to do today is, or this morning, is to give you a broad idea of our three expert speakers with a geographic, a technological, and in part an academic profile on this issue. Some ideas as to where they personally think that the UK is going. And we're hearing this discussion, of course, on the day when Mr. Pickles has done his usual thing and crashed into the issues at King's Lynn. It looks as if £30 million of public money is going to be going back in the form of a cheque to the bankers and the advisors for the long drawn out refusal now to allow King's Lynn to do what it originally decided in the way of energy from waste. We don't really want to talk around specific issues, however. We want to give you a flavour of the general background matrix around issues of risk and expectations from those already in the market or as regulators. Our three speakers will be batting in the order of Nigel Mattravers. Nigel's got a distinguished background working for various external consultants in this field, and he's now involved in chairing international conferences. He runs his own business, advice business in this area. And in particular, he's heading up the IMECI work, looking at this area in terms of balancing the technological challenges. We then have Rolf Stein, CEO at Advanced Plasma Power. Rolf is actually a lawyer, but at APP, he's got a firm interest in looking at the competing options in the so-called advanced thermal technology area. And he's going to give us a run through there. And last but by no means least, Jasper Roberts, who's Deputy Director for the Waste and Circular Economy Challenges in Wales. And Jasper also has a varied external background. He's involved in affordable housing, community housing, and indeed covers the ground in what many would regard as an ideal population scale to implement some of these policies. So let's kick off. We've got 5 to 10 minutes from each of our speakers. Let's kick off with Nigel, and then what I want from you is some active participation at the end in terms of challenging questions for our speakers to make it worthwhile both for them and for you to come together today. So thank you very much, Nigel.
Well, thank you, Peter. Good morning, everybody. You'll notice as a marked absence of slides from me. Obviously, I didn't understand the briefing properly, so I'm just going to talk from some notes, if you don't mind. Recovering energy from waste is controversial, but I do believe it still fits very well into the waste hierarchy. But as Peter inferred, I think we should be looking beyond almost the UK obsession with mass burn incineration of municipal waste. So much of the conversation we have is always around that particular issue. Hopefully I'll talk about some broader issues and the different opportunities that the new technologies make for us, but some of the risks associated with that, with these new technologies. Most in the sector believe that energy from waste is better than landfilling. However, some dispute this, arguing that from a carbon and the global benefits of EFW are overstated. So in this case, we've really got to think beyond the conventional energy from waste facilities and consider anaerobic digestion and advanced thermal conversion technologies in terms of efficiency. Conventional energy from waste has provided a valuable way of diverting waste from landfill in Europe. And to a large extent, this has been driven by the landfill directives and its targets associated with it. But it must be remembered in many jurisdictions, and at the moment I'm thinking places like Hong Kong, where landfills are running out and other separation and treatment options are difficult to provide, then conventional energy from waste may well provide a viable and sustainable solution option and provide a vital role in managing waste and also for providing energy. Because energy from waste can provide a very good base load for energy supply. It's also a secure supply in many ways, and indeed can provide other products other than electricity and heat, such as fuels and chemicals. In terms of security, a good case in point is the Ineos Clor Viridor project at Runcorn, which has not been driven by the need to dispose of Manchester's waste, but by the need to provide a secure energy supply for the Ineos Clor plant, who's one of the biggest energy off-takers of demand in the UK. And as I mentioned, although the efficiency of conventional energy from waste is disputed by some, it is generally recognised that advanced thermal technology is developing and is capable of delivering high level of efficiencies. And in this country, we're beginning to see that happen with a major development of advanced thermal technology with the Air Products facility at Tees Valley, which ultimately, when the two lines are in operation, will require nearly 1 million tonnes of waste before sorting, and that will essentially deliver electricity with the opportunity to deliver hydrogen in the future. So much of energy from waste development has been driven by the directives, legislation, and incentives that have been put in place. And sometimes some of those incentives have been a bit perverse in what they've done. But the future will be seen as using EFW in its various forms as a way of producing higher valuable materials in the form of gas, liquid fuels, and chemicals. We're also seeing much more development of symbiotic use of energy from waste, where factories are using their waste products to develop energy, which is then going back for use within their own plants. I mean, Rolf and I were at a conference in Amsterdam a couple of weeks ago, where we saw a very good project in the south of France with a major paper mill, who were recovering the energy not only from their waste paper, but also from the stumps of the trees that actually were being the feedstock for the paper. Now, the technology wasn't without difficulty, but again, that seemed a very good example of the symbiotic use of energy from waste. But one of the biggest challenges to any of these new projects is finance. It's been the stumbling block of many a good project. And the issues that really make it difficult for the finance community are issues such as land and planning. Is the site suitable? And what is the risk of getting planning permission? And we've just heard of a case this very morning. Feedstock. How will this vary across the lifetime of the project? We're already seeing we make things differently, we recycle things differently. The composition will vary across the time of the project. And how can we guarantee the volumes that are needed? Technology. There are many around, but are they proven? And will it treat the feedstock that is actually going to be delivered? Again, a case in point, project in Finland. They thought they knew what the feedstock was, and until they actually started using it, they realized there was stuff in that feedstock that they didn't know was there, and that interfered with the performance of the technology. And then markets. Can we find a market for the products, be it electricity, be it heat, be it chemicals. And how will that output vary with the feedstock? Because the feedstock changes and the output will vary. And project management. Who is going to be behind the project? Who is actually going to make it deliver? All of these things make the finance market quite difficult. I also briefly want to mention the RDF market. We've seen a large flow now of refuse-derived and fuels going across to Northern Europe. Overcapacity of facilities in Europe has made this happen. But what it's led to be doing is the diversion of very low-grade materials from the UK into Northern Europe, up to about 1.6 million tonnes last year. And I've just seen the news that a new contract has been signed to send 60,000 tonnes of RDF to Latvia. Now, is this the best use of a UK resource? And it's also enabled a lot of rubbish, literally, to be exported. I remember one of the major importers from Europe said, we'll take the waste anyway, all we need to do is blow a hairdryer over it, and that'll be good enough for us. Is this the right way for us to go? I'm going to say in conclusion that energy from waste has a future, but it may well look very different from what we have now. The energy may well be in the form of fuels and chemicals and electricity and heat. But the real challenge is going to be, can we get the finance to make it happen? Peter, thank you.
Thanks for that, Nigel. Certainly a key emphasis there on risk and the fact that there's a growing sense of disillusionment, really, about the prospect of an economic return in the UK. Perhaps Rolf would like to comment on that and in terms of the way that these different technology options either clarify or confuse the picture. Over to you, Rolf.
Thank you, Peter. Thank you, Nigel. So I'm going to talk a little bit about a very specific process option, which I'll explain in a little bit. But first of all, some scene setting. So as a planet, essentially we're full. In the next 40 years or so, we expect our population to increase by another 2.6 billion, up to 9 billion people, and produce what is now about 1.3 billion tonnes of waste a year, increasing to 2.2 billion tonnes of residual municipal waste a year. At the same time, we face another significant challenge in terms of sustainable energy generation, as well as, of course, reduction in consumption. Now, there are many options to generate electricity sustainably. Obviously, wind, which is being deployed widely. It doesn't produce base load. We have options such as nuclear, which are seen as low carbon, in terms of the whole life cycle, which do produce base load but are very expensive. And we have conventional energy from waste, which could put this residual waste into, or is putting residual waste into very good use. However, has certain limitations in terms of efficiency and other options, as well as certain implications environmentally. So I've got a bit of audience participation for you. I wondered if anyone in the audience could tell me what these are. No? Okay. Well, I think they're resources. So we have currently in the UK, about 20 million tonnes of commercial industrial waste going to landfill. Most of our municipal waste is contracted on a long-term basis, but those contracts will renew. We have significant quantities of waste stored in landfill sites, some 2 billion tonnes already landfilled in the UK. We produce a significant amount of agricultural waste, wood waste, and the plastic residue from auto shredding. All of these are materials that could be put to better use than putting them in the ground or letting them decay. This has to be seen in the context of two things. Firstly, the volatility in the fossil fuel market, and nothing could have brought this into sharper focus than recent events, which I'll speak about in a second. But here we see just the natural gas price in the US. Obviously, it's come down in recent years due to the impact of fracking, but we see a very significant volatility in prices. The other thing, of course, to note is that currently around 95% of our hydrogen, which is seen as a replacement transport fuel, comes from methane or natural gas cracking, and is currently by no means a green fuel. Again, in context, as I mentioned, natural gas reserves, about a third of our global reserves are located in the former Soviet Union, in particular in Russia. And of course, recent events have brought into very sharp focus the whole issue of energy security and our dependence on gas in particular. The great news is that we actually do have processes that are emerging that can convert the waste resources that I mentioned earlier into syngas, essentially, hydrogen and CO, for use as both an alternative fuel, but also in the production of chemicals and other gaseous and liquid fuels. The key process step here is what's known as gasification, and then the cleaning of the resultant gas in really a number of different ways, but typically either through thermal cracking or through some kind of scrubbing technique. Why go to the trouble of this? Well, in the on-site power generation context, it has very significant implications for the efficiency for the conversion of basically waste into electricity and also heat on site. So steam turbines typically have an efficiency of up to around 25%, assuming relatively high temperature combustion, which has maintenance issues due to corrosion. Gas engines in single cycle have efficiencies of approaching 40%. Gas turbines in combined cycle about 50%. And we're seeing fuel cell technologies emerge, in particular solid oxide fuel cell technologies that can take syngas directly and convert it into electricity with efficiencies of approaching 70%. Now that technology is still relatively nascent, but is evolving, and consequently we'll expect to see some very significant improvements in on-site power generation efficiency. But that's not the only thing you can do with this syngas. I mentioned alternative applications, so yes, on-site heat and power generation, but it can be converted through a methanation process into substitute natural gas, for instance, for injecting into the grid, and I'll talk a little bit more about that, or into pure hydrogen to use as a transport fuel, into liquid fuels, and in some cases the solid residues, the ash, can also then be converted into a product through a vitrification step. For instance, our own technology produces something we call plasma rock, which can be used as a building material and is completely environmentally inert. So in terms of bio-SNG, we're currently working on a project with National Grid and Progressive Energy to demonstrate the conversion of syngas, which we produce on our plant in Swindon, into bio-SNG or biosubstitute natural gas. National Grid's own calculations see that the combined impact of biogas and methane generation from gasification from waste sources and from biomass sources could amount to as much as 20% of the UK's gas demand. So we are talking about a pretty significant contribution if all of that material were put to better use. So we've secured funding for the project and are about to go into construction of that facility, which will take about 12 months and will go into operation around this time next year. And that was all I had. Thank you very much.
you very much indeed, Rolf. And finally, we come to Jasper Roberts, who's going to present some of the challenges to you that he, and indeed opportunities that exist in the Principality. And it's been quite notable, of course, over the last few years, how the devolved assemblies and the Scottish Parliament have seized the level of independence they've been able to secure around this particular area. And indeed, Wales in particular is a beacon of light in some otherwise grim municipal statistics. So over to you, Jasper.
Thank you very much. I hope you can hear over there is a bit of background hubbub coming in from outside, but I hope you can all hear. Thanks. My name is Jasper Roberts. I'm responsible for waste policy and resource efficiency for the Welsh Government. The question we were asked to address, what is the future for energy recovery? Well, I think in Wales we consider that the future is a good one. And I want to talk to you about some of the commercial opportunities that we're trying to create in Wales for the future. But it is perhaps a more limited role. It's not a free-for-all about maximising the amount of energy from waste. It's a balance between environmental outcomes and commercial opportunities. I fail at the first technical hurdle. How do I get the thing to move on? I'm pressing like anything, but it won't go.
Keyboard as well if you want.
Okay. Okay. Thank you. Now, this slide sets out the policy background in Wales. For us, our starting point in waste management was more about recycling. It's about the top end of the hierarchy. Energy recovery is a good thing. It's better than landfill, but it sits in about the middle of the hierarchy. We're trying to move up towards the top: waste prevention, reuse, recycling, and avoiding landfill. Renewable energy is a very valuable byproduct of more environmentally sustainable waste management, but it is not for us primarily a renewable energy strategy. I've set some of the headline things there: 70% recycling for domestic and commercial wastes, 90% for C&D, and we are expressly attempting to limit the treatment of residual waste by means of energy from waste to no more than 30% of the waste stream. I think the figures are slightly different elsewhere in the UK. Does it have a future? Yes. Our strategy documents make that very clear. Residual waste phased out of landfill, food waste diverted to anaerobic digestion. We have a residual waste capacity around 1.5 million tonnes. And we reckon there's around 500,000 tonnes of commercial food waste available for anaerobic digestion. For those of you not familiar with the devolution model, we have primary legislative powers in Wales now, just as the Scottish Government does. And we recently published an environment bill for consultation. We are attempting to create a context which encourages higher recycling in business as well as local authorities. We've set a statutory target for local authorities of 70%. We're trying to create that same driver through legislation for the business community by pushing towards source-separated materials, specified materials, improved collection for source-separated wastes. We're looking to specify not just the 4 materials in the European directives, the classic ones of plastic, glass, card, paper, etc., metals. We're looking at also wood, food waste for inclusion. And we're also proposing, and this is still open for consultation, so your views would be welcome, we're also proposing a ban on landfill and a ban on specified materials to energy from waste. This can't be an absolute ban. We're not looking to impose that. That would be unworkable, but we're looking to drive up the capture of recyclate to that 70% sort of figure, and any contaminated waste, any residual waste which may still contain some residues of potentially recyclable material, that can still lawfully go for incineration. We've also asked in the consultation about a ban on disposal of food waste to sewer, because we want to capture that waste to go through anaerobic digestion. I may be confusing you because I've got different slides on the screen in front of me from the ones that you've got on the board. Let me just go back a second. Done that one. That's just some of the support we've provided for municipal waste. We're in the throes of building half a dozen anaerobic digestion plants, and we've got 1, 2, possibly 3 medium-sized energy from waste incinerators in the pipeline. That's the environment bill proposals that I've just mentioned. Energy from waste bans. The purpose of this, moving up the waste hierarchy. We identify there the materials we're looking at banning. We'll have to have some exceptions for some materials. It would not apply to anaerobic digestion. We are having to look carefully at the impacts and implications for biomass, because that obviously relies a lot on wood. And as I've said, it wouldn't be an absolute ban. It must be practical. It must be workable and proportionate. So what are the opportunities? We've got a shortfall in Wales for both anaerobic digestion and energy from waste. We reckon, as I mentioned, around 500,000 tonnes of food waste that we need to capture in a better environmental way, and that will require treatment. Our preference is for anaerobic digestion. We reckon we've got about 1 million tonne shortfall in energy recovery capacity. Incinerators in Wales are coming out around about anywhere between a couple of 100,000 tonnes, 350,000 tonnes, a much smaller, more practical, more bankable scale than some of the plants in England. So if we've got a 1 million tonne shortfall regionally distributed, we could be looking at 3 or 4 plants, probably northeast, southeast and southwest central. So there are quite good commercial opportunities, we believe, there in Wales. Interestingly, slightly off the subject, but we reckon there's up to 3 million tonnes of dry recyclate for which we have a need for a reprocessing capacity in Wales. So we are encouraging reprocessing companies to come and talk to us about the commercial opportunities for setting up to tackle that material. And our role, apart from creating the legislative framework, is to help business seize these commercial opportunities and make the investment, create the jobs in the Welsh economy to deliver these sorts of tonnages that I'm talking about. Along the way this morning, we've heard mention of some of the challenges, the difficulties, finance, land availability, planning. Yes, they are all issues, but if they're addressed properly and managed properly, and as I say, we've got 6 AD plants in the pipeline, several incinerators, these are manageable problems. They need management, they're not easy. There is still a certain amount of public opposition to conventional incinerators. I'm sure it'll move on to the new technologies when they arrive, even though at the moment people are advocating the new technologies as an alternative to conventional incinerators. But if you have a proper dialogue with the public in advance of developing facilities, you can manage those planning issues. I don't cast those issues aside. There are important issues to get across to the public about health and environmental impacts of these types of technologies. And that's a debate we have to have, but it can be done. Finance is an issue, but it has not proved a showstopper in the projects we are developing in Wales, and there's been a variety of financial levers that we can pull, and we've had a few ups and downs, as one does with procurement, but by and large our projects are very bankable. And of course we ourselves have land, as Welsh Government we have land available that we offer to the market for, for the development of these sorts of facilities. So that's a very rapid tour of our direction in Wales, legislation, involvement, catalytic approach to commercial investment, encouraging the market to come and invest with us, and that is the direction we hope to take these technologies in the future. Thank you very much.
Thank you very much indeed, Jasper. Well, it'll be tested on the Welsh for reduce, reuse and recycle at the end of this session as well. It's good to see that the Welsh language is always pretty sort of ingenious at the way that they come up with these words. So, diolch yn fawr. Right. The issue that I'll get the ball rolling, if I may, with the first question to our panelists. We've not heard an awful lot about the sort of carbon trade-offs that surround these issues. I just wondered whether you all felt comfortable that there was a single sort of coda or methodology that you're all comfortable with where we could actually look at these balances, because if we consider, for instance, in Wales, the opposition to thermal oxidation plants, well, yes, maybe, but if you look at a thermal oxidation plant with combined heat and power co-located through the fence to, say, a paper mill, you end up with a different carbon balance compared to AD plants that are a long way from motorways, dependent on a high proportion of agricultural slurries that don't actually then put the gas into grid, maybe. So do we have enough metrics here to actually be sure that when we're talking to the public or the planners that we're comparing oranges with oranges and so forth?
Should I pick up on that one first, since you mentioned Wales? We believe so. There is a science to this. We've looked very carefully at the environmental performance of all the options. We quite consciously preferred anaerobic digestion over in-vessel composting. We have, as a matter of agricultural policy, because the Welsh Government is also responsible for agricultural policy in Wales, we haven't gone down the route of energy crops. We're just dealing with domestic and commercial food waste. There are technical and other issues involved with mixing agricultural and other wastes in AD. On the incinerator front, we again have looked very carefully at the science. We have preferred that approach, high recycling and energy from waste, as opposed to MBT, for example. We decided some years ago not to invest anymore in MBT technologies. We've looked at the rate analysis. There are critics of rate, and there are some issues, but it is still a useful tool. But the one thing we do insist on in Wales is high energy efficiency in incinerators. We want 60% plus. It's a requirement of all the incinerators we are supporting that they are CHP enabled. There's an interesting heat network project under discussion in Cardiff from the Viridor incinerator. We would not accept incinerators that do not have high electricity and heat and power performance. And that tips the carbon balance. There's some interesting work done by DEFRA about the balance as the electricity supply chain is decarbonized. But we think if we have high efficiency energy from waste, the balance is still in favor of it.
Thanks. And Nigel, the Institute of Civil Engineers has been leading the charge on this for some years, hasn't it? Do you feel that we're beginning to see the mist clear on this issue of efficiencies and so on?
I think the simple answer is probably not. Just on your point you just made really about the carbon balance, it is quite a difficult one, and I think the numbers on which it's based are changing. And so people now say, well, actually, the figures for landfill are wrong, and maybe actually some well-known proponents are actually saying we should give up energy from waste and go back to landfilling, which for old wasters like me is something that we've probably talked before. It is very difficult to have a hard discussion just on carbon. And we've got to recognise for an awful lot of energy from recovering valuable materials from waste, including energy, there are other drivers as well. A lot of that has been initially from landfill directives and the like, but there are other issues as well. So it's not just carbon, but nonetheless, we should be looking at higher levels of efficiency all the way through the process. But you can very easily get caught up and spend many hours, months, arguing about the finer points of carbon calculations, and it doesn't help us go forward sometimes.
And Rolf, as we go up the technology curve, of course, the sunk capital investment to get to our megawatt of energy goes up as well, doesn't it? So how do you see this challenge?
Well, so on the subject of carbon and life cycle carbon in particular, I think I'd agree with Nigel. I think it's pretty opaque at the moment, and certainly from a cradle to grave perspective, I think is not well understood. So the various processing options, I think, in isolation probably are, and I think most developers of advanced thermal plants, conversion plants, will have a good understanding of what that improved efficiency means over conventional incineration and landfill. But then how that all fits into whether the recycling should be undertaken on a more centralized or decentralized basis, source segregation, all those kinds of things, and the impact of transport more generally on size of facility, I don't think is particularly well understood, and is very complex, and it varies from site to site. But on the subject of economics, I think you're absolutely right that obviously as these technologies emerge, they are invariably going to be at the expensive end, I guess, of the options available. But that has to be seen in the context of the development cycle. They're very much at the beginning of their. We're very much at the beginning of the learning cycle, whilst incineration, for instance, is nearing the end, and we would expect to see significant efficiency improvements, but also cost improvements as supply chains are developed and so forth.
Fine. Well, can I throw it open to the floor now then, ladies and gentlemen? Yes, sir. We've got a roving mic there, so if you could just indicate for everybody's benefit who you are, where you're from, and nominate either the entire panel or one individual to answer your question. Thank you.
It's Deepak Lal from South Prime. Question for Jasper. It's all well and good having a set of rules and regulations in Wales. How do you prevent waste moving across the border and people arbitraging the rules?
Good question. I mean, waste, as we know, is a very mobile industry, and a lot of our landfill already goes to England. That's England's good fortune, I guess. By and large, if we have the facilities in Wales, the trend is that people will use them. Part of the problem is that we don't have them, and there is no driver to create them. So as we see the larger scale taking off in other parts of the UK, there is all our dry recyclate, for example, goes by, a great deal of it goes to England to be reprocessed, and of course the added value and the remanufacturing opportunities then follow on in the economy in England. We need to repatriate some of that resource and some of that added value, and the way we propose to do it is through the stimulation of the development of the facilities in Wales. If they're competitively priced, as they are, the experience so far is that they are very competitively priced, then the incentive will be for the markets to function satisfactorily in South Wales, and the waste won't go to England. So whilst that is perhaps a bit of a leap of faith rather than a regulatory approach, our experience of the market is telling us that is what is actually happening. But as government, we've had to get off our chairs and make that happen.
But if that was the case, you wouldn't need to implement any new rules and regulations. If it was economic anyway, they'd be doing it.
There are many conflicting things in the economy. We're trying to ensure that the most environmentally sustainable ones come out on top, by making sure that people recycle more and so forth, and recycle in particular ways that make the material available for reprocessing. At the moment, that's not happening. There are other things happening. So we're trying to change the market, and if we create the conditions for that market to change, then we think the market will respond, and the evidence is that that is happening.
Dave.
Thank you. Dave Hampton, Chartered Environmentalist. A slightly jovial question, perhaps, on the subject of green leadership, and possibly on the import of green leadership from Wales into the UK. Thank you for Wales's leadership, and thank you, Peter, for yours. We haven't got much time, have we, as a planet? Speaking last hours of ancient sunlight. Is it possible that the Prime Minister, David Cameron, was actually badly misquoted and understood when he referred to allegedly green crap? Do you think that perhaps he was very prescient in seeing the value of waste streams and compost, recycling and the circular economy, and that actually he's onto the true value of waste and resources.
Who wants to bat first? Nigel.
Oh, thank you. All right. I'm not going to make a particular point about the Prime Minister and his own particular views. I actually sat on the Conservatives' Quality of Life Commission before the last election, and I was quite impressed really with the commitment of the people there to look at all of the issues. I think even what we've talked about today is quite clear that it isn't clear what are the best solutions, what is the right way of working, and there's obviously conflicts within the present government as well in England about what is the right thing to do. Having worked in Wales and knowing the work that Jasper's had, it's been completely different in Wales, where you've got a very positive approach and supportive with money as well as land and all the other things, whereas within England there's been this big step back and let the market sort itself out. But on the other hand, if what Peter was saying about King's Lynn, that is another case in point, where we have a facility, and if that's now been rejected by Mr. Pickles, some of the advisors who have been responding to this, who are meant to be very sustainable advisors, are actually saying, well, why don't we just export it to Northern Europe instead? Is that right from a sustainability point of view? I don't know. I don't think there is a clear answer to the green question.
Like Nigel, it's not for me to comment on what goes on in other countries of the United Kingdom. What our position is evident from what we're doing, and it's interesting to think back to the first question about the carbon balance and so forth. A few years back, Welsh government, we took the view that we didn't have the luxury of not doing anything. We had to cut through the conversations that were going round and round in circles about what to do, and we sought to take the best choices on the best available evidence at the time, and that is what we have done. And I don't think, suffice it to say that I don't think it would have happened without some central leadership.
I hope the thrust of what I was saying was that, we are missing an opportunity, and so but again, won't comment on the Prime Minister's own particular views. But certainly, I think from the appeal to government is to coordinate a little bit better than certainly has been the case, and it's been a very fragmented policy approach from DEFRA through to DEC. I think hopefully the shift of some of that, or preferably all of it, to BIS would be a positive step in terms of bringing some consistency of approach and actually seeing it for what it is, which is it is an economic opportunity as well as environmental, and it's has connotations for energy security and a host of other things as well. So I do believe we can learn from others and should grasp the nettle. And the problem with a market-led approach is that it tends to default to the easiest and lowest cost, not necessarily the best option.
And just developing that theme, Dave, I think that there is a great opportunity insofar as only this morning, yet again, we're seeing now a lot more muscle being expressed about the almost charlatan-type claims that are coming from those discussing the issues on people like the BBC and so on, where they seem incredibly unable to distinguish between sound science and cant and opinion. And I think that we're beginning to see now that as the evidence emerges before our very eyes, that there will be an expectation from within the sector, I think, to be a lot bolder and more robust in actually getting back to sound science, because for so long now, others have had that arena and run with the ball. The waste industry itself is only now coming out of its shell, I think, in terms of seeing that it's not disposing of a problem, it's actually managing something like 3 times the mass of material that's going into the retail side of the economy, 160, 170 million tons of stuff. Now, in any other economy, that would be seen as an opportunity rather than a threat. So does anybody in the room have a view about this sort of issue? Have we undersold ourselves? Well, if you do, you're not actually putting your hands up. Can I take some other questions then? Thank you, sir.
Hi, my name is Chris Watts. I work for a company called Reliance, and we provide security solutions for the energy sector. A couple of questions really, I suppose, or two in one, is I think everyone on the panel has talked about the challenges that there are getting some of these projects off the ground in relation to economic, land planning, etc., etc. I just wondered why it's proving so difficult given the need for the UK to reduce its carbon footprint. Quite a broad question, I understand that. But secondly, Nigel, you mentioned about the Air Products facility up at Teesside, and I just wondered also whether there are any lessons that can be learnt from those particular projects that can be used elsewhere to help move this forward.
Yeah, quite happy with that one, because Air Products is a great example. As we've heard elsewhere, governments, I use the word, have this general belief in where we should be going and a general view that how we should be our targets for renewables, but they're leaving it very much to the market. And therefore, when people with a very good proposition go to the banks and say, please, Mr. Bank, will you lend me some money to do that? Well, these guys then look at the risks that are there and which government has really got very little to do in terms of helping. We're hearing again today they're not helping necessarily in terms of planning. The feedstock is by far the biggest issue. How can you guarantee that you've got that feedstock of that composition for the period of time we need to pay off that plant? And with economies changing, with the way we recycle changing, the feedstocks are always changing. And then there's about the risk of the technologies. There's lots of new, bright technologies out there, but who's going to be putting their money into them? And again, the end markets. So that's a challenge, and it's something that the government hasn't been prepared to do. Air Products at Tees Valley, I was speaking at a conference with them the other week, and that they admitted if they'd gone to the bank, nobody would have given them the money. Air Products, luckily, are a very, very large firm. They are also essentially a chemical industry, obviously one of the world's biggest chemical firms. They feel that they understand the technology, even though it's never been used at this scale. The last time it was used was in a plant in Japan, and that's just shut down. So they're taking a huge risk. There's a huge risk on where all the tonnage is going to come from, but Air Products feel that they're big enough and chunky enough to take that risk on. And so I think that's where the difference is. These things are going to happen where people have actually got the ability to put their own money in. But talking to banks and the like is a bit more of a challenge. Okay.
Jasper, you're in a position to control that process a little more directly maybe in Wales.
It's a very interesting question. It sometimes seems to have been far more difficult than you would have expected to be. There are a number of factors at play. We are currently carrying out a lessons learned exercise around our procurement program, and we will be publishing that in due course because we think we need to learn from that experience for the future, for future private sector development. But I'd highlight a couple of things. All too often this gets very political and very party political, and the small number of objectors, although as I said earlier, we have to take their concerns very seriously and address them. Nevertheless, the small number of die-hard objectors has a disproportionate impact on planning decisions and so forth. I've also seen some very poor decisions taken by funders, some very poor risk assessment, appalling risk assessment of anaerobic digestion and association of it with more complex and more challenging technologies, and that's led to bad funding decisions. Some very slow decisions by funding partners that haven't matched our procurement timetable, so we've had to dump some high street banks. You do wonder about the competence of our banking sector. But luckily, we've always managed to find alternative funding routes. On the point of guaranteeing feedstock, Of course, that's exactly what we've sought to do with our 70% recycling rate and our proposals for private sector wastes. We can identify the exact tonnages, well, I say exact, more or less exact tonnages that will require treatment by various means in the future in Wales. We can give people that guarantee that they can scale their investment proposals to meet those needs.
Thanks. I think in answering the question, we can't forget the sort of the context again that we're only just really beginning to emerge from a pretty significant recession that has made funders very sensitive indeed. But with that backdrop, I think there are sort of two principal reasons. One is that conventional technology returns just aren't sufficiently attractive to attract the funding, and are often having to be supported by, previously things like PFI credits to achieve that level of return. They're obviously not there currently, so those facilities are underpinned by, often contracts where you have to question, is that value for money? These are gate fees that are higher than landfill costs currently. So there's that angle, and the newer technologies have the issue of of risk, and whilst they might overcome that return hurdle and do, no one wants to fund them because it's no one wants to be first. So it's but then people like, or companies like Air Products, obviously, the technically capable buyer will enable, I think, ultimately the technologies to come to market. But it needs that kind of intelligent money coming in.
And it's interesting to see that coming in from people that have a core business around the conversion process. In Air Products' case, hydrogen, CO/CO2. And indeed, they've had experience many, many years ago. They used to run incinerators in New York. So it's not as if they're just an industrial gases company that's going into the waste industry for the first time. They have been there before.
Could I just add something quickly? We're seeing quite a lot of innovative funding developing as well. Entrepreneurial venture capital groups coming to talk to us about opportunities, and they're bypassing the conventional funding routes. They're faster, they've got a better, more realistic risk assessment, and they're very eager to find investment opportunities. And we're very eager to talk to them.
Yeah, we're looking to put in a village anaerobic digester, actually, so we're now getting to grips with cloud funding. Any other questions, please? Yes, we have one at the back. Thank you, sir.
Hello, Sam Haig from Action Recycling. First, quick question about the economics. Would it be right to say that a lot of the economics is driven by the gate fee that's received for the material coming in? Do you all agree with that? Yeah. Yeah?
Fundamentally, yes.
Yeah,
So,
I mean, the split's different for different technologies, but yes, there is a definite contribution from gate fees. Yeah.
When we went to market back in 2009 for our AD and more importantly the residual program, we were technology neutral. It was interesting who bid and who didn't. Companies with novel technologies didn't feel market ready at the time, so that was a factor as well. Gate fees obviously fundamental, because at the end of the day it's what it costs you. But we're getting some very good gate fees now because of the scale of the projects we've set up.
Okay, thanks. So the follow-up question is, if we reach the utopian scenario where no waste goes to landfill and all waste is treated in some essentially commercial facility, does the gate fee not then go on the free market essentially, and how does the viability of something that's competing with landfill tax work on the free market, where there's could be all sorts of fluctuations in gate fees?
Yes, I think the key there is the free market. And I think the case, I think, and particularly with knowing the business that you're in 2008, I think just before the recession, well, before the crash, I would say, certain collection companies were actually offering free recycling to local authorities, and some even said they would pay for it, because the belief was that the value of the recyclates was so high that in fact they didn't need to charge a gate fee. Unfortunately, that didn't last very long, and when the markets crashed, then those businesses fell over. So in utopia, yes, we believe if we can separate these materials, if we can get the value for that, then the need for a gate fee will reduce. And certainly I know that business cases for certain plants are working in that direction, that as the volumes change, then in fact they are assuming that the gate fees will reduce, and that is going into a lot of business cases. But equally, from a financier's point of view, you know, when you go to them and say, this is my assumed value of mixed plastics, and my value of sorted papers, and my product of biofuel, well, it's still quite difficult for them to take that risk as to what that market is going to be. Yeah.
The other thing we need to do is create a much greater demand for recycled material in remanufacturing. The demand on that side isn't strong enough yet, but it's coming.
I don't think landfill anymore is the lowest cost option. So I think you already have to compete. For instance, in the export market, you know, is driving gate fees down. So you know, to be competitive, you already have to be less than just the tax alone. So you know, I think, and I think getting back to the point of underpinning the facilities, yes, they do require, funders will require long-term feedstock supply agreements on the basis of a gate fee that's pre-agreed. That might be, you know, it might be escalated, might be inflated over the course of the contract, but so then it's for the supplier to take a view as to where the market's going, really.
Yeah, sorry, just going to just follow on from what Rolf was saying there. Yeah, we've got a distortion at the moment by this ability to export RDF, SRF to Northern Europe. They got that spare capacity by accident because they got their strategies wrong. But what is going to happen when all that capacity is taken up? You know, we're going to get more and more if Norfolk's waste now heads off to Northern Europe. If we're getting Italian waste or Greek waste being sent up to Northern Europe, then that capacity may disappear. What happens then? You know, we are at a sustainability conference. Is exporting waste to Northern Europe sustainable in the long term? It might provide a short-term solution at the moment, but is it sustainable? I don't know.
Could I add something? Because on that sustainability point, I mean, Welsh Government has a statutory duty to pay heed to sustainability principles. And our objectives are not just about the best management of waste. They're about economic development and jobs and the society impacts of all these things. There's a balance between price and other economic and non-economic outcomes, which is quite, you know, at the centre of what we're trying to do as well.
I suspect that this also touches on the fact, something that Rolf alluded to, with the growth of global population. For me, it's about the growth of global bourgeoisie. 300 million people a year, approximately the original EU6, being added to a middle-class consumption demand on our restricted planet year after year after year over the next 15 years or so. So you will see the value of these resources start going up. And I personally think that we're just in the foothills of this process. But I saw a hand there. I'll have to make this the last question, I'm afraid, but over to you, sir.
Thank you. Rob Wakely from the Department for Transport. I just wanted to reassure Rolf in particular, but other members of the panel, that we are very keen on the economic growth opportunities from developing advanced fuels, in particular from waste. And that's something that we are putting a lot of effort into at the moment, and indeed have got an allocation of 25 million to actually set up a competition on that. But where do you see the opportunities for transport fuels from waste?
So we've done quite a lot of work on the route to hydrogen, so waste and waste biomass to hydrogen as a kind of natural adjunct to the work we've been doing on bio-SNG, because the first step of that process is a shift to change the hydrogen CO ratio before the methanation stage. So we understand that well, and consider we've got a very good proposition and offering in terms of current conventional hydrogen production routes, particularly steam methane reformation, with being the lowest cost option. We can compete against that. So if renewable hydrogen is likely to carry a premium, and we feel we're in a good place as far as that is concerned. We haven't done a great deal of work on because we're typically smaller scale. Not that we have to be, but that's what we focused on. So sort of the 50 to 150,000 tons a year of RDF, something like that scale. And so we haven't done a great deal of work on Fischer-Tropsch, the whole conversion to liquid fuels. But you'll be aware of the projects that are being developed in that regard. The challenge there, I think, is the efficiency and the economics of the FT process, which still aren't good at smaller scale, but there are companies who are hoping to break that situation. So we keep a keen eye on those.
And there's no silver bullet in this process, remember. In my book, the last one standing will have to do three simple things. If somebody gives you 1 billion gigajoules of input feedstock, you have to achieve 60, 70, 80% of those gigajoules as a saleable product at the back end, whether that's recyclate, energy, combined heat and power. Secondly, you've got to sell that output at the highest possible price per gigajoule. And then thirdly, you probably have to do it within a lower carbon footprint if and when the government decide to actually adopt an aggressive carbon strategy. And if you do those three things, you can outcompete anybody else for the feedstock when there are more of these facilities than there is a feedstock availability. What a lovely world. Anyway, the reduction of time, I'm afraid, has overcome our ability to either recycle it or reuse it. So I'd like to ask you to congratulate our panelists on their presentations, and I'd like to thank you for being such a positive audience in terms of the variety and interest of your questions. Thank you very much indeed.
Hello. Okay, welcome everyone. Welcome to the Water Industry Technology Pitch. My name's Steve Kay. I'm Head of Innovation at Anglian Water. And we've got 4 inspirational speakers to talk to you today, but they have to do it in 5 minutes. So what we're going to do is take the 4 presentations and back to back, and then we'll take some questions at the end. So we've got David Holmes, Raymond Hoon, Kevin Honer, and Nick Mills. They'll introduce themselves, I'm sure, at the start and say what they do. So if you leave your questions till the end, and be as challenging as you want to be, and hopefully we'll have a good session. So without further ado, if we start with David Holmes, who's Technical Director of Fiberlight.
Good morning, everybody. 8 and 1. 8. Oh, sorry. My name's David. I'm the Technical Director at Fiberlight Composites, and my responsibilities are technical innovations and product development. And I'm here to talk about composites, and in particular, FRP composites. So, what is a composite? It's two dissimilar materials, but we're specifically talking about FRP, which is fibre reinforced plastic. So you have a resin matrix, and inside the internal structure, you have long-term fiberglass. So we term composites as a new innovation. It's not actually. It's been around since the 30s, and Fiberlights have been manufacturing FRP manhole covers for the past 30 years. So, what are the products we manufacture? We manufacture trench covers. These are a modular trench covering system that are ideal for trench pits and trenches that accommodate service supplies. And these can be made in bespoke sizes, and we can manufacture these products from load ratings from A15, which is 1.5 ton, metric ton, to F900, which is 90 ton. So they're extremely strong, but very, very light. Fiberlight was the world's first company to attain kite mark to BS EN 124 past 26, which is the European standard for manhole covers. We have a kite mark license to produce C250, which is 25 metric ton load rated covers, and D400, which is 40 ton D400 load rated covers. I mean, we make, as you can see, we make quite an extensive and comprehensive range. You can have the covers either color coded for identification, or you can have bespoke company logos actually molded onto the cover surface itself. We also make electrical draw boxes and junction boxes, containment systems to keep electrical connections dry and contamination free. These are manufactured in both products are manufactured in a closed mold environment with steel tools, and these guarantee consistency of wall thickness and performance and quality. One of the major issues with steel, ductile cast iron and concrete infill covers is their weight. And at Fiberlight, we pride ourselves on lightweight but extremely strong covers. I mean, this photograph is a typical, This photograph is a typical cover replacement procedure in the top right-hand corner with a large cast iron cover, 2 men with what are referred to as picks removing the cover. It's extremely hazardous. If you look at the Fiberlight cover, which is down at the bottom, it's a single man lift with a specifically designed, ergonomically approved lifting handle. So, these are the load ratings. As you can see, A15 is for pedestrian load ratings, and we go right up to F900, which is for ports and docks, and we manufacture all the load ratings in between. So, to the benefits of the fibre light covers and also GRP covers. Load ratings from A15 to F900. A wide range of colours and shapes. Customised bespoke options are available for retrofit. So this means we could manufacture a cover to be retrofitted into your existing frame. It's a chemically inert product. It's unaffected by underground gases and most chemicals. Completely maintenance free. You fit a fibre light cover and you forget it. There's no repainting, nothing will corrode, and nothing will crack, crumble, or delaminate. They're completely sealed and water and odour tight. They're an excellent insulator, as composite is, against heat. They're very easy to remove and replace. They actually weigh about the third of a cast iron replica cover. The lifting handle eliminates back injuries. Okay. Warranty for 15 years, incredibly strong monolithic product. There's no bonded joints, excellent skid resistance, and as you can see, the benefits go on and on. So it's out with the old, and it's in with the new. Thank you very much.
Thank you. Okay, thanks, David. Out with the old, in with the new then. We'll move over to Raymond Hoon, sales manager at Scott Vickers. Thank you.
Okay, good morning, ladies and gentlemen. My name is Raymond from Scott Vickers. Okay, I actually come from Singapore. Okay, what I'm going to introduce to you is ClearTech system, which our company actually manufactures it. Okay, what the topic is today is treating construction site silty water runoff in Singapore. Could it work in UK? Sorry, give me a moment. Sorry. Okay, can we go back to the slide, the first slide? Skip that. Okay. Okay. Okay, so what? How should I do it?
2 seconds.
Thank you. Okay, sorry for the delay. Okay, water treatment in Singapore. We have about over 90 inches of rainfall in Singapore per annum, where in UK, okay, we did a search. Okay, UK has approximately about 45 inches per year. Okay, in fact, Singapore is a very small area. Okay, it's only about 710 kilometers square. Okay, and we have very heavy water demand because of the population there. Okay, 2/3 of the total land area are used as catchment for water supply. In fact, we also have to buy water from our neighbors. And over 90% of all silty water discharge actually comes from construction sites. Okay, so the government actually gave us a regulation of we are not allowed to discharge more than 50 ppm of water out of the construction area. Okay, generally what you see is before treatment, okay, you will see it's very muddy. It's like a tea with milk. But after treatment, okay, what we will see is water that is literally very, very clean, but it's still not drinkable. Okay, this is a typical layout of a construction site, okay, where this is the whole site. Okay, you will have your hoardings around, sorry. Okay, you have your hoardings around the whole site where we will build perimeter drain. Okay, whenever there's a rain, waters that actually comes into your site will fall into the drain and be diverted to a sedimentation tank here. Okay, after the sedimentation tank, we will have a treatment system where you'll be connected to, treat the dirty water, and it can be discharged out of the site here. Okay, so in your perimeter drain, we actually encourage you to have silk fence so that you can actually corner off all the big items. This is a typical picture of a sedimentation tank in a site.
10 seconds.
Yeah. Okay, and this is the silk fence cut-off drain, okay, where you have the silk fence. These are just some of the examples of the equipment. We have a 20, 60, 40, and 80. Okay, this is a typical water system, treatment system. Okay, where the water will actually comes in from here, goes into your primary chamber, go into a secondary chamber, and the water will actually go out as a discharge.
Okay, great. We're going to have to finish there, I'm afraid.
Yeah, okay.
Okay, thanks very much.
Yeah, thank you very much.
Did you give him some injury time there, some extra time? Because he's had a delay at the start. Yeah, okay. Thanks. Okay, Kevin Hooner is next.
How do I close it?
Kevin is marketing manager at Draeger.
How do I close this one and get the other one open? I'm just thinking. It's probably escape, isn't it?
Yeah. I think you have to do a bit more.
That's it. That's mine, isn't it?
Yeah. I let it run a little bit long, but I assumed it added something to say. Yeah. Extra time. That's what I said, injury time.
Well, good morning, ladies and gentlemen. See if I can get this microphone in a suitable position. I'm going to say a few words about things that have changed in portable gas detection over the last few years. I could take a lot longer than 5 minutes over this, so I've picked to focus on one thing which I can present in about 5 minutes. But first of all, what has changed? If you look at instruments now and compare to what was on the market 10 years ago, they're a hell of a lot smaller and a hell of a lot lighter. They're not much bigger than mobile phones. That means it's practical for people to wear these on a daily basis as part of their protective equipment. That's been a major change in what's going on in the gas detection world. The second thing is the move towards daily function testing of instruments before use. This is because sensors in instruments can fail in a manner which cannot be disclosed, and we need to be certain these instruments are working. So increasingly, people gas test these instruments on a daily basis. Thirdly, so-called docking stations, automated calibration stations, have become increasingly commonly used, and these not only provide for the calibration of the gas detectors or the function testing of the gas detectors, they provide a lot of backup facility in terms of managing issue and receipt of instruments, and therefore providing asset management, tracking of where products are. And fourthly, what I'm going to focus a couple of minutes on, the use of infrared as a gas detection method for flammable gas rather than the conventional catalytic sensor. Conventionally, for flammable gases, and we're talking here about gases like methane or other hydrocarbons, we've used a catalytic sensor. This is a device where the gases literally burnt at low temperature, generating some heat, and that heat is used to measure the amount of flammable gas that's present. This type of technology is very well established. It's been around for a very long time, and the sensors are simple and relatively inexpensive. Typical lifetime of these sensors is about 2 to 3 years, but they can be damaged by the presence of other materials in the atmosphere. So typically, some organic materials, when burning on these sensors, they cause loss of sensitivity. Presence of H2S, hydrogen sulfide, which is commonly present, of course, in wastewater systems, causes loss of sensitivity of these gases. So an alternative is to use a purely physical principle. Rather than using a catalytic reaction, which is a chemical principle, there is a physical principle which is capable of monitoring flammable gases, and that's the absorption of infrared radiation. So hydrocarbons, which most flammable gases are, absorb at a specific wavelength in the infrared, and this absorption allows you to relate the concentration of flammable gas in the atmosphere to the signal you get out of the infrared detection system. What are the benefits of this? There's no way, unlike catalytic sensors which can be damaged or poisoned by the presence of materials, there's nothing to poison. It's a purely physical process. Secondly, there's no routine degradation of the sensor. So you get a long lifetime. You can actually have sensors last at least 5, maybe even 8 or 10 years, which is a reduction in maintenance costs. There's no way it's going to fail and not tell you it's failed.
About 30 seconds.
Okay, that. And it's reduced calibration because you only have to calibrate annually instead of every 6 months. Disadvantage is the higher initial cost of purchase. Now, as the price of infrared has come down, so the gap between the cost of using an infrared sensor versus cost of using a catalytic sensor has closed. And on a current calculation, it's possible to argue that the reduced calibration completely offsets the increased purchase cost of the infrared sensor. So over a 5-year period, this should be just about cost neutral. I see that as getting actually more favourable towards infrared sensing technology as prices continue to come down for the more complex components involved in that.
Okay,
so thank you.
That's it. Well done, Kevin. Thank you.
That keeps roughly to my...
Okay, and last but not least is Nick Mills, who's a project manager at Thames Water, working in the area of sludge and energy innovation. Nick.
Thank you. Great, so yes, I'm Nick Mills. I'm going to talk about a concept which we've been developing called advanced energy recovery. And yes, we're going to talk about sludge just before lunch. So why have I got a job, really, is this question. Why does sludge need innovating? And there's a huge pressure on our land bank. More commercial anaerobic digestion is competing with our land bank, so we need to find options that aren't recycling to land. Renewable energy is a big driver. There's economic drivers, there's regulatory, there's carbon saving, which means that we're encouraged to do more renewable energy generation. And the sheer cost of energy is getting astronomical. Our energy bill, electricity alone was £100 million last year, and that's due to rise significantly. So we luckily have a resource in our hands. Sludge has the same calorific value as wood chip and some types of coal. And for anyone that's shaken my hand during this event, that's not my picture. They are not my hands at the top of that. So what do we do at the moment in terms of recovery from sludge? This is using anaerobic digestion, and we take about 1/3 of the energy out, potential energy in sludge, and convert it into a biogas. There's a technology that the industry, including Thames in a big way, are now delivering, which is THP, thermal hydrolysis, is an advanced digestion pre-treatment. It improves and has other advantages, but it doesn't get us up there. And this is where advanced energy recovery comes in. It allows us to convert all of that energy pretty much post-digestion. So how do we do that? And this application works best on a THP site with digestion, where we've got a gas engine. And dewatering technology is very key, and we've identified high dry solids dewatering as the key step post-digestion. Gives us a smallest amount of water to remove with drying, and the drying has to be sustainable, and I'll come on to how we achieve that in a minute. But it's low temperature drying to produce a product that's at about 90% dry solid, so 10% moisture content. And at that point, advanced energy recovery processes, we're talking gasification and pyrolysis, become feasible. So you end up with a fuel gas or a syngas coming out of that process, or a char and an ash, which you can then put into a second CHP unit, and you've pretty much doubled your renewable energy output from a site like this. And you obviously got heat that goes back into the drying step, hence sustainable. No fossil fuel required, very efficient, safe dries, and even the low temperature ones aren't even ATEX rated, so it's a very safe technology. It's not drum dryers with all the accidents that we've had in the past in industry, which has put us off. So there's the concept very quickly. What next is a full-scale demonstration plant. We're currently investigating a number of technologies for the advanced energy recovery box. So there's a competitive tender happening at the moment, and I want to find an investor, spend something like £14 million to build exactly what I've just shown you. And the paybacks are looking very, very good. We're looking 4 to 6 years, and the application in the UK is quite enormous. So that's my pitch. And I've got 1 minute left. It's brilliant.
Okay. Well done, Nick. Time to spare. Thank you. Okay, well, you've given us an extra minute for questions there, so...
that's backfired.
So well done to all our speakers for getting their messages across. Would anybody like to ask any questions? We've got about 18 minutes, and then the next session will start. So any questions from the floor for our speakers? One down here, front. I think we've got a microphone coming around.
Okay, my name's Mark Booth. I work for United Utilities, and it's a question for Nick really, because the whole area of digestion and CHP is a big area for all water companies. So in essence, can I just ask a bit more explanation of this? So we're almost doing the digestion process as we used to, and then you're taking almost the cake out the back end of the digester process and reworking the cake.
Exactly. Is this on? That's exactly what we're doing. And what we have identified is these advanced processes are very good. They've moved on. Other industries are delivering these things at full scale. So really, we're stealing ideas from other people here. But the concept is digestion first. Digestion is one of the most efficient energy recovery methods. When you compare it to these post-digestion methods, you want to do digestion first. Reduce the volume that you've got to treat. But yes, exactly. We are recovering post-digestion.
Okay, and I don't know whether the graph was to scale, but it was almost suggesting that you were getting double the benefits.
Yes.
Wow.
That's what we're saying. And also, these technologies sit in a different category for the rocks. So the incentives drive you to do this. Yeah, but we wouldn't envisage not doing the digestion first.
Yeah. Okay.
Okay, thank you. And just to build on that, Nick, one from me. Have you looked at putting gas back into the grid rather than converting it into electricity?
Yes. Yeah, we've got a plant at Didcot, which is a biomethane injection plant. So we have looked at it. The economics with the RHI make it very attractive, but when you've got processes requiring heat on site, for the advanced digestion sites, we didn't go forward on the sites that we're building now with biomethane. And personally, I've done a bit of work on the environmental and the sustainability of biomethane injection, and the incentives are very well placed.
Okay,
yeah.
Thank you. Any other questions? Question, well, one from me, David, about your covers. I'd just like to ask you, have you looked at the embodied carbon of GRP covers compared to other conventional materials?
Is that on?
It's on there.
Okay. Yes, we have, and the manufacturing process makes the GRP access cover almost carbon neutral. One of the biggest advantages is that we are using recyclable reinforcement within the internal structure, and also there's no onward carbon footprint as far as maintenance costs are concerned, because it's a completely maintenance-free product.
Okay, thank you. Anyone else? Any other questions?
Can I ask a question? Can I ask a question about that? How many have you got in the road being driven over by lorries 10 times a day? Yeah.
We don't... there we go. We don't actually have a highway offering for the access cover. We currently believe that the most appropriate product for the highways is a ductile manhole cover, and we are somewhat cost prohibitive. So when you do look at the cost of a GRP access cover, you've really got to look at TCO. You've got to look at total cost of ownership to really identify the benefits.
Okay.
Okay, question at the back.
Yeah, I was very interested in terms of RHI claims about your sustainable thermal drying. Could you just give me a brief outline of how that works?
Yeah, it's fine. We're struggling here, aren't we? It's about the biomethane plant we've got at Didcot consumes an awful lot of propane, and it's regarding the displacement of carbon-intensive electricity with the supply chain for natural gas. So there's a bit of work we could probably follow up and talk about afterwards. But the RHI...
So I meant the actual technology, because I think drying digestate is an eligible use for RHI of heat. So if it's a sustainable one, obviously this has quite an effect. I mean, you could have an unsustainable version of drying digestate, which boils off the water, but this sounds like a different thing.
If I understand correctly, the numbers I showed you there, we have to assume no benefit from RHI for the drying. It's literally to get the job done with the heat that we have on site.
So you're not looking, this is not a new piece of technology, this is just the word sustainable in that you're using the heat for drying?
Yes. That's all it is, just words.
Okay, anyone else? We've got Raymond and Kevin there, getting off lightly at the moment. So, okay, well, I'll ask a question. Kevin, sorry, your gas detector. It looks a sort of safer option, but how does it compare on cost to conventional detectors?
If you look at the actual sensors involved, the infrared sensor is probably 3 times the cost of a standard catalytic sensor. But when you take account of the reduced maintenance frequency and the reduced calibration frequency and the cost of that, it just about balances out. And it's getting closer all the time.
And if you can sell them in high numbers, will the cost drop even more?
Yes, anything that you manufacture, the larger the volume you manufacture, the lower the manufacturing cost. We have seen a step change downwards in the cost of manufacturing infrared sensors, as not just for portable instruments, also fixed gas detectors on sites. The infrared sensors for those are much less expensive now than they were relatively, say, 10 years ago.
Okay, thank you. Okay, question at the back?
Question for Raymond. What's the largest site you've installed this technology on?
Okay, in fact, in Singapore, we are talking about, in general, the largest site will be somewhere about 30,000 meters square. Okay, where we can, you can have actually a few equipments put at site. It doesn't need to be just one. You can actually have multiple equipments at site.
Thank you. I've got a question for you, Raymond, actually. You talked about a process that looks quite impressive in terms of dirty water becoming clean. But what are the advantages? You know, what are the advantages of doing what you're doing?
Okay, the advantages of actually having this filtration system is you can actually recycle the water. Okay, you can actually use it into other usage, such as cleaning of the site, refilling this washing bay. okay, even dust suppression, you can actually wet the site so that you don't have so much dust at site.
Okay, thanks. Any more? Okay, well, if you've got no more questions, we'll close it there. And if you'd like to give a big hand to all our speakers for doing an excellent job.